Hi, I'm Steve Matthews from ACOEM. Today we're going to walk through a precision laser shaft alignment with the ACOEM AT-100, the newest addition to our laser shaft alignment product line. The AT-100 is tablet or app-based and communicates with the sensors through a Bluetooth connection. So the first thing we're going to do is turn on our sensors. At the same time, we open the horizontal shaft alignment app on the display unit. And you can see that the display unit is searching for the sensors. And if we touch on the settings icon, we can look and confirm that my sensors are indeed connected. You see the check boxes are complete on the sensor serial numbers. So this generally only has to be done the first time you use the unit, and after that they connect automatically. So the first thing we're going to do is get everything set up correctly. And in the setup we have two chain brackets here and a stationary sensor and a movable sensor. Generally the stationary going on the side that you don't plan on moving, and the M sensor going on the motor or the side that you do plan on moving. And so in the setup, we have the chain brackets on the shafts, and then we have a laser on each sensor shooting at the other side. So this is a dual laser system. And in that setup, what we need to do is aim the laser. It is a line laser, so it is very easy to aim, but we do the aiming by moving one sensor or both sensors up and down on the post. So now I have each of my laser lines in the center of each sensor. The next step, of course, is also going to be that our sensors need to be square to one another. And we can double check that by looking at the angle display on the display unit. In this case, I have the S sensor at 8.9 and the M sensor at 8.5. So these should be within about 1 degree of one another to start off with. So now that I have everything set up, we can go through a precision shaft alignment. But the first thing I'm going to do is this display is currently oriented as if you were standing on my side of the machine for the demonstration. What I'm going to do for the sake of the camera is reorient the picture so that the motor or the movable machine is oriented for the camera side of the demonstrator. So this actually comes in handy during the alignment process also. As you tend to move around the machine from one side to the other, the picture can be reoriented to where you stand. Next step is going to be to enter the dimensions of the machine. First thing I need to do is enter from M sensor to S sensor. This should be done within about the nearest 1/8 of an inch, and in this case we have 7 inches. So we have 7, check. The next dimension is from M sensor to the center of the coupling. In this case I have the default value of half the distance between the S sensor and the M sensor. If it's not, you can change that to what the actual measurement is. So then we have from M sensor to the front feet of the movable machine or the motor. In this case, you can see if I use my chain as a plumb bob that my M sensor is straight over top of my motor feet. So that dimension is 0. Next is from the front feet to the rear feet of the movable machine. Here we have 7 inches. Next, I'm going to select the tolerance for my alignment. Tolerance is generally based on machine speed. The faster a machine rotates, the closer we want to be with our alignment tolerance. I will select 1800 RPMs for this alignment, and our chart has 4 selections. If you want to use your own selection for a tolerance, there is an opportunity to input a user tolerance. So we hit the check box, and again, you'll see each next step of the alignment process is generally highlighted in yellow. That's part of what we call our guide you user interface. So what we're going to do now is something we call a vertical alignment. We're going to take one set of shaft alignment measurements and complete both the vertical and the horizontal adjustments in one step. So I will hit the measurement icon, and in an AT-100 we use our tri-point measurement method. In tri-point it requires us to take 3 measurements, and the measurements can be start anywhere and stop anywhere. In other words, there's no requirement to use clock positions in tri-point. So I'll take my first measurement at this location, which is somewhere between 9 o'clock and 12 o'clock. And once the measurement's complete, you'll see a red zone and a green zone. All you have to do is rotate outside the red zone in order to take the second set of measurements. And the little lollipop on the rotation will turn green or red depending on whether or not you can take a measurement. So now I take my second measurement. And then finally rotating around for a third measurement. Again, just need to get outside the red zone for each subsequent measurement. It's also important that you not move the shaft while it's taking measurements. So you saw that little dancing dial. Once the measurement's complete, then you can move to the next step. But it's important not to move the shaft while it's in the measurement process. So now we have a presentation of data, and what you can see is all red, meaning that all of my values are outside the tolerance. So the top set of values are the vertical values, and then the second set of the lower set of values are the horizontal values. So you can see this is where the angle and offset are vertical, angle and offset horizontal. And then the numbers underneath the machine feet indicate how much I need to adjust the machine to get them within tolerance. So at this point you see some positive numbers and some negative numbers, and you'll see in the next step exactly what that's going to mean in terms of where we move the machine. So next I'm going to hit my shim icon, because shimming is generally done first. My vertical adjustment this is why we call it vertical. The vertical adjustment's done first, and the horizontal adjustment is done second. So there is a choice offered here. If the user wants to save the data at this point to have a before and an after, you can save the data. That's what this icon is. In this case, we're going to make the adjustment and then save the data after our final alignment is complete. So now you can see we have a picture that's drawn to represent what the positive and negative means. So an arrow going in means I need to add shim underneath those feet. And in this case, I've got front feet where I need to add 21 thousandths, and then rear feet where I need to add 37 thousandths. So I've already got some shims pulled out here to make these adjustments, and I am going to loosen all 4 feet at the same time and take my shims for the front feet and make that adjustment, and then my shims for the rear feet, 37. Okay, so I am going to leave, again, the movable machine will be left loose at this point because I've done my vertical, I need to do my horizontal now. So again, here we have the green and glowing icon to indicate the next step is the horizontal. So now what we have is a live picture of the horizontal. So as soon as I start moving these jack bolts, you'll see it moving on the screen. So I need to go 50 thousandths in the rear and 35 in the front. So I'm going to hit the rear one first. It's got quite a ways to go. And you can see the arrows are actually scaling to how much adjustment is required. So you can see I made a big adjustment on the rear feet, and that arrow got a little bit smaller. And then also, once you get within tolerance, you see the angle and offset values turning green. Okay, so now and then the check mark means that both the angle and the offset have been satisfied in terms of the tolerance. So once we do that, our alignment is complete. So we're going to tighten down our bolts, but we're also going to come back and remeasure. So when I remeasure, that's going to be when we document this alignment with a report. So here's my remeasure button. Once again, we'll take a series of 3 measurements. 1, rotate outside the red, take a second measurement, and again to a third and final measurement. Once again, it's important not to rotate the shaft while the instrument is measuring. Okay, so now we have a complete alignment, which I can confirm by looking and seeing that I have a green check mark and a green check mark, and all my tolerances have turned green. So the final step here is going to be to document this alignment, and that is done here. We're going to save the alignment. So there's 2 steps to this. We're going to save the alignment. I'm going to call this AT-100. All right, so that saves our alignment, and then we're going to produce our final report by combining the shaft alignment with, if we had saved data from a soft foot adjustment beforehand, we can do that as well. So in generating the PDF report, there's several lines available for putting a plant name in, a user name in, a machine name, and any machine notes that you may have. And so we'll select the AT-100 and soft foot, and then save it. And then this creates the PDF report, which is a combination of those 2 reports put into one. And now we have that file saved for future reference on this device. So that completes the shaft alignment process with the ACOEM AT-100. If you have any questions about this product or its use or any of other product line, please contact us at the details below.